Okay, so today we're starting, and we're gonna this whole week. Girls' eyes up here. This whole week we're gonna be talking about exponents, properties of exponents. Our regular textbook takes like 4 sections to cover this. This textbook we're using, this is the last chapter we're doing in this textbook, but this textbook takes 1 section. So we're gonna spend 3 days on 1 section of this book because I think these properties are definitely important for you to understand, and they take a while sometimes to grasp. So, what does 2 to the 5th mean? Yes, Marie. Oh, okay. You should get one. Yeah.
2 to the 5th power.
It does mean 2 to the 5th power. That's why I said, what does 2 to the 5th mean? Jake?
Me?
Yeah.
Oh, it means 2 times 2 times 2 times 2 and then times 2. That's why it's...
I wasn't keeping track, but did you say times 2 5 times?
Yeah, I did it on my...
You should have said times 2 4 times. 2 times 2 times 2 times 2 times 2. It means...
that is 5.
Yes, that's 5. But really, you only had to say times 2 4 times, right?
Times 2 4 times.
Yeah, but you had to say 2 5 times.
Right.
Yes. So there are 5 2's. Well, you say it, Brendan. 2.
2.
Okay. Times 2. Times 2. Times 2. Times 2.
Oh,
Okay. Anyway, it means that you have 5 2's that are being multiplied together. That's what it means. This power right here tells you that. Okay? Now, how many already knew that? Okay, very good. I want you to open your workbooks up to page 168. Just wanted to make sure we had that down. This, by the way, is called expanded form right here. When you take something in like an exponential form and write out an expanded form. Okay. Page 168 is where we're at. I want you to go ahead and work through exploration 1A, 1B, and 1C. Okay? 1A, 1B, 1C. Without a calculator, please. Put your answers... Hey, right up here. You're working through 1A, B, and C without a calculator. You're putting your answers in exponential form. That means you're not giving me, like, if I said 2 to the 5th power, or if I said 2 times 2 times 2. This would change to that. I don't want the answer of 32. Okay, I want your answer in exponential form. Exponential form would be like 2 to the 5th. Okay? Go for it. You guys get about 5 minutes or so to do your best work on it. Work with your partners, people around. Okay, let me pause you for a minute if I can get your attention back up here. Just to make sure that we're all kind of on the same page. So it says, what happens when you multiply 2 powers with the same base? First, you kind of need to know what a base is. Your base, what's the base of this? 2 squared. Well, actually, that's a bad example. 2 to the 3rd. What's the base? 2. The big number is called your base number. Okay, so if you didn't know that, that's a good thing to take a note on there. Okay, when you multiply 2 things with the same base, so they both have a 2 there, write the product of the 2 powers as a single power, then write the general rule for finding the product of 2 powers with the same base. So this right here, if I have 2 squared, expanded, that's 2 times 2. And I have 2 cubed. There's a multiplication symbol in between here. So we'll put a big symbol there. 2 cubed is 2 times 2 times 2. Now you hear me say 2 squared. That means to the 2nd power, that's squared. And to the 3rd power is called cubed. So 2 to the 2nd, or 2 squared, times 2 to the 3rd, or 2 cubed is 2 to the how many? Yeah, it's 2 to the 5th. We have 5 of them. Okay? So using that general rule, the quick way to do that, tell your neighbor what the quick way of finding 2 to the 5th is versus writing it out in expanded form. What appears to be the quick way. All right, very good. Wrap up discussion. Toki, what do you think?
Just add the 2 numbers to the top.
Good. Add the 2 powers up there. Okay, Patrick, is that what you guys got over there?
Yeah.
Is that what Brendan's telling you?
Yep.
Cole told you that? Yeah, okay. So yeah, we take these two, we add them up. So 2 to the 5th is really 2 squared plus to the 3rd. Okay, so we just add those two powers together. Okay, that gives us our 2 to the 5th. All right, now how many of you did that? Okay, so this one actually became 4 to the what? 6. 5 to the 8, and x to the x to the 8. All right. Dude, it's tough. All right. So if we're writing a general rule would be something like if we said, hey, if we have a to the n power times a to the m power, what's our new base going to be? Annalise? A. What's our power going to be? Keegan, what do you think?
NM.
Yeah, n. Are we multiplying the two?
Yep.
Do we multiply them up here?
Oh, no.
No. So n plus m. Yeah. There is a time when we have nm, though. And it's actually in one of these next few. Good. So that's a general rule. This is called multiplying your two powers here. We're going to summarize all these rules here in a while. Okay? How many remember that from last year? From previous? Okay? All right, let's try letter B. What happens when you divide two powers with the same base? Well, here you multiplied with the same base and you added. What do you think you do when you divide them? Yeah? Subtract? Everyone agree? Okay, so this would actually be the base of 4 to the 3, the top, minus the bottom, minus 2, which is 4 to the 1st. Okay, knowing that, I want you to go ahead and finish that section, or at least check it with your neighbor real quick. Okay, far be it from me to hold you guys up because most of you are done with this. Okay, Jennifer, what do you have here? 2 to the 3rd, 5 minus 2. Okay, base right here is what, Audrey? X. And the power is going to be, yeah, it's going to be the 3rd power. Kyla, what's our base here? 3. And what's our power here? JC? That's our base. So we're going to subtract these two, right? What do we end up with? Yeah, 0. It's kind of weird power. Zeros are here, though. That's a special... Yeah, it is. Okay?
Wait, do we have to write 0? Can we just write 3?
No. You'll see why here in a minute. Could write another number. Okay? So, if we summarize it, everyone using A, and I'm going to write it like this, N and M, go ahead and summarize it up there. What's the rule? You could either think of it like that, or if you want, you could think of it like that. That's a bad A. Almost looks like a 9. Go ahead.
What is 3 0? Is that just 3? Or
3 to the 0, we'll see it here in a minute. Yeah. We'll go through it. It's a good question. It's inquiring minds want to know. All right. What do you end up with there, Caden? See you telling Lily.
A n minus n.
Good job. Did Lily agree?
No.
Oh, unbelievable. All right. Letter C, what happens when you find a power of a power? So here you're finding the power of a power. Write the expression as single power. Most of you had this done. So Cole, what did you think?
I said
You multiply them? So if I have 2 squared to the 4th power, that means I have how many 2 squareds? Ryan, how many 2 squareds do I have here?
8.
I don't have 8, no.
Oh, you have 4.
I have 4 2 squareds, which I think what you meant by the 8 was you end up with 2 squared, which is 2 by 2, times 2 squared, which is 2 by 2, times 2 squared, which is 2 by, oops, I messed up, by 2, and then 2 by 2. You end up with 2 to the 8. So that becomes that. All right, so if you guys ever forget these rules, you can always just expand it out, write it in expanded form. That's 2 to the 8th power. So a power to a power, you multiply. Anytime there's a power to that parenthesis. That's the quick route. Okay, so this gives us 7 to the 6th, x to the 8th, and y to the 9th. So a to the n, all to the m power, is equal to a to the... Jaden, what do you think? NM? Yeah. All right. Very good. Questions? How many seen Teenage Mutant Ninja Turtles? Saw it last night. It's pretty good. Yeah, the new one. I was kind of scared there for a while, but they ended up working it out. All safe and sound now, Toki. Not worried anymore. All right. Next part. Everyone turn the page, please. Page 169. What happens when you find a power of a product, and what happens when you find the power of a quotient? I want you to complete letters D and E with your groupies there. As I kind of saw walking around, looking at your paper, some of you got stuck really fast here. Like, I saw multiple answers for this one. The one I saw the most common was 10 to the 2nd power. Who put 10 to the 2nd? Seems logical, right? You multiply what's in parentheses. You say, okay, I just go 10 squared. And everyone knows 10 to the 2nd is what? It's 100. It's equivalent to 100. Okay, now we've left everything in exponential form, but I want to point out another way to do this. Now, just so you know, the way I would do this problem, if I was to do it on paper, is I would do exactly that. I'd multiply the 2 and then square it. The other way to do it, though, is to take this and bring it into each. So you could think of that as 2 squared times 5 squared. And if you're not sure that you can really do that, you could say, well, 2 squared is 4. And 5 squared is, what is 5 squared? 25. And what's 4 25s?
3.
It's not 30.
What? I didn't even hear your question.
425, then you shouldn't respond. 4 25s is 100. 4 quarters is 100. All right.
I was doing
You good? Yeah, I would say. So what we're looking for right now is this. Okay? If we're looking at this one right here, Jake, what do we end up with?
What do you end up with?
Mm-hmm. Not 20 cubed.
Yeah, well, that's what I got. So.
Okay. So applying what we did here, which is what I was trying to explain a minute ago.
Right, sorry.
So what would you get?
You would get... I don't know what 25 to the 3rd power.
Don't worry about that. Write it in this form.
Okay.
Exponential form. Someone help Jake out. What do we do there, Chelsea?
Wait, I'm almost there. Oh, Audrey says I'm not. So
Okay. Chelsea, what are we doing?
We do 5 to the 3rd power times 4 to the 3rd power.
Okay, so Jake, you're paying attention now, right? 5 cubed and 4 cubed. So it's that quick. We're just bringing that power into each other.
Oh, I already had that.
Okay. So 6a to the 2nd. Bobby, what could I bring the 2 into? Notice up here you have 2 times 5. Down here, what do you have in here?
6 times A.
You have 6 times a. Now they don't write it like that. They just write it as 6a. But if you have 6 times a squared, what's another way to write that?
6 squared times A squared.
Okay, yeah, you can bring that into each. 6 squared times a squared. And that's why we look for those patterns there. Because in this one, really we don't know what a squared is because we don't know what a is. So the way to simplify this, we end up with 36a. So if we kept going on this, we'd actually finish it off with 36a to the 2nd. like that. Now that's what I'm going to be expecting today, is for you to follow through on this and actually multiply the 6 out, but not multiply the a out because you don't know what it is. Okay, so using that logic, I want you guys to do, that's Roman numeral 4, but do that one there. 3x quantity squared. What would that end up being? You try it and then check it with your neighbor there.
Really smart to be able to transfer from this to an actual.
All right. Who have I not called on? Hey, Ayla, what do you got? You got one? Huh? 9x squared. Ayla says 9x squared. Do I get a second for that? Anyone second that? Get it? Squared? Like second? 9x squared. Well done, Ayla. 9x squared. 3 squared times x squared. Jake, did you get that?
Yes.
Yes. Well done. All right. So let's write the general rule. If I have a times b to the m power, write out the general rule. A times b to the power of m. Okay. So Toki, what's one thing you're raising to the power of m? A. A to the power of m. Do we raise the b to the power of m? Yes. Yeah, b to the power of m. Okay, we got to bring it into both parts. All right. Hey, I forgot to congratulate everyone today. Everyone has an A as of today.
Yeah.
I know. You did very well last semester. The majority of you had a very good grade after the final. Well done. But everyone has an A right now. So beginning, everyone starts fresh.
Straight A's.
Yeah, straight A's today. It's good stuff, man. Well done. All right.
I'm going to Harvard.
Okay. Sorry to get us distracted, but the last two rules we've had a power outside of parentheses. And anytime you have a power outside of parentheses, kind of like the distributive property we did early on, kind of like when you've done this type of problem in the past, you know that you distribute. Whenever you have a power outside the parentheses, it's kind of like distributing it as well. Okay, you got to bring it into both parts. Okay, it's kind of a similar idea. It's not the same thing exactly, but that's really what you're doing here. It's what you did on letter C. On letter E, what do we think we do with this 2? Outside of parentheses. Tell your neighbor what you take a guess if you're not sure. All right, Lily, what do you think? Should I raise anything to the second power? Yeah, which thing? Okay, so we'll raise 2 to the second. Did anyone else say you should raise 2 to the second? Someone make Phil. How many agree with Lily? You should at least raise 2 to the second. Okay, I agree there. Okay, what do we do with the 3? Raise it to the second, I heard. Who thinks we should raise it to the second? Lily, should we raise it to the second? No? No? All right, I'm going to tell you have to. You have to bring it into both parts. All right. So really, if we were to simplify this completely, that would be 2 squared over 3 squared, or 4 over 9. Right? Because 2 squared is 4, 3 squared is 9. 4 over 9. Make sense? No? Try letter or number 2. What would that become? It's called Roman numeral 2.
Oh.
Just Aish.
So wait, like.
So wait, like.
You know how Star Wars counts? That's what you
Nice. All right. Mackenzie, what do you think? 4 to the third over 3 to the third. So you went like this. Okay. TT, you agree? Yeah? Okay. I agree too. 4 to the third is what? What's 4 times 4 times 4? That is 64. Well done. And 3 times 3 times 3. It's 27. That's very good. Well done. Okay. Good job. All right, now we get to the general. Go ahead and finish those last two there if you haven't done so. Let's check it. This is x to the third over 2 to the third, which is x to the third over 8. This is a to the fourth over b to the fourth. Very good. How many got them both? Well done. Let's write the general rule. Go for it. I'm not going to give you the letters this time. You guys use them. Make up your own letters. Like you could use your initials. That'd be cool. Toki, what are your initials?
TP.
I know, but what's the middle initial?
K.
TPK? TKP? So if we use Toki's initials. Nice. Pretty cool, huh? You gotta tell me how cool it is, Toki, I know. Mm-hmm. That's a Toki math problem right there.
Attaboy.
All right. If you have the same initial like me, MM, but I have 4 initials, so I'm good. I could just substitute one out. Yeah. Some people are cool like that. Okay. Any questions? How many feel pretty good about it so far? Okay. Now, we're going to skip the bottom of that page. I do want to take a look at this part right here. This is on page 170. And just to define a few different things. Okay? First one is a power. Use a problem to define the power. Like if I gave you a to the 5th, what would a power be? Which thing is called the power? Okay? Use maybe a to the 5th to define these first 3 pieces. Okay? All 3 of those pieces are found in that. Okay? Power, exponent, and base. Okay, so our power, in a to the 5th, what's our power? Go ahead, Marie. Huh? Yeah. The 5 is the power. Okay? What's our base? Yeah?
I did Burley to the 5th, and I said the base is Burley.
Yeah, that's true. The base would be Burley. In this case, it would be the A, but you're right.
Burley's my last name.
I noticed, yeah.
You came up with that idea.
The whole thing, this whole thing is called an exponent. Okay, so when we put our base and our power together, we get this thing called an exponent. All right. Even if you use Burley to the 5th. Okay. Very good.
You guys should use Burley.
We're impressed. Scientific notation. Scientific notation works like this. It says if you have, and we're not going to go into this a lot, okay, right now, but scientific notation takes a number that's between 1 and 10. Okay, it has to be less than 10, but between 1 and less than 10. So for instance, give me a number between 1 and less than 10. Yeah.
Me?
Yeah.
1.
1 point what?
7.
7. Okay, 1.7 times 10 to the power of something. You have a power up here. That is called scientific notation. So maybe we use a power, we make up our own power, like 3. Okay, we use this to represent really big or really small numbers. So 1.7 times 10 to the third, well 10 to the third is 10 times 10 times 10, or 1,000. Okay, so when I multiply 1.7 times 1,000, it actually just moves this decimal 3 places. So that decimal that was there moves 1, 2, and 3. Okay, it becomes 1,700. You guys tell me if I'm off the screen like that. Come on, man. Otherwise, you can't see. Okay, this is scientific notation, the 1.7 times 10 to the third. is the scientific notation. And if this is a negative power, the decimal moves the other way. And we'll spend more time on that on another day, but that's really what it is. Okay? All right, two powers that we didn't talk about. One is this one right here, 4 to the 0 power. Brendan asked this. He said, hey, what is it if it's to the 0? Well, if it's to the 0, it equals 1. Okay? And you could figure that out just by looking at a pattern. If I said 2 to the third, 2 to the third is 2 times 2 times 2, or what? Come on, 2 times 2 times 2? It's 8. What's 2 to the second? 4. What's 2 to the first? Okay, how do I get from 8 to 4? Divide by 2. How do I get from 4 to 2? Divide by 2. How do I get 2 to here? Divide by 2. What's 2 divided by 2? 1. Anything to the 0 is 1. That pattern works every time. Like if I did 4, if I did the same thing and I said, well, 4 third, 4 squared, 4 to the first, and 4 to the 0, I'd go through that same process. This is 64. This is 16. This is 4. I keep dividing by 4. 4 divided by 4 is 1. Anything to the 0 is 1. Anything to the first is itself. Okay? Which means if I go to the negatives, 2 to the negative 1, well, I'm going to divide this by what? By 2. That's 1 over 2. Or 2 to the negative 2, I'm going to divide this by 2. Well, 1/2 divided in half, I have half a dollar and I divide that in half, what do I have? 0.25 or a quarter, or 1/4. 1/4 is the same as 1 over 2 squared, by the way. So when you have a negative exponent, you just put this, whatever this is, pay attention here. I see some of you zoning out. This is really when you need to pay attention now. When you have a negative exponent, you write it as a fraction. Okay? That 2 goes to the bottom and the negative becomes a positive. That's what's saying down here. 4 to the negative second is really 1 over 4 squared. A to the negative n is 1 over a to the n. So it's just whatever power you have, it becomes a fraction. So you kind of got to think of this part as a fraction to begin with. And just say, well, it's a negative exponent. I just move to the other side of the fraction, and it becomes positive then. That's what's happening. Okay? Jake, you think you got that? You look pretty intense. Okay. Jaden, you got it? How many think they got that? Okay, well, if you really think you got it, what happens if I give you this? B to the negative second and a 1 on top. What do I do now? I can't leave it as a negative exponent. That's like a no-no with exponents. Yeah.
Make the 1 a negative, or like?
No. It's an idea. How did I make this one a positive? Yeah. I flipped it. I changed the level. I brought it to the other level. So how am I going to make this one a positive? Yeah? Good. Yeah, I'm going to move it to the other level, which makes it b squared. That's the answer. So it just changes levels. So if it's on the bottom and it's negative, bring it to the top, now it's positive. If it's on the top and it's negative, bring it to the bottom, now it's positive. That's how it works. That easy? Yep, it's that easy. Okay? All right. We got it? Now there's a whole nother page here before we even get to the assignment, but the good news is when you start looking at page 171, we've done all these. These are the ones we did in our exploration. They're just examples for you. Product to a power, a to the m times a to the n is a to the m plus n. Quotient, a to the m over a to the n is a to the m minus n. Okay, and this is where n can't, or a can't be 0. That means because you can't divide by 0. Power to a power, a to the m times a to the n or a to the m, quantity to the n power is a to the m times n. And then we've got our product to a product, or power to a product and power to a quotient. All right, that's for your reference. I want you to take a look at page 172. Page 172 is your assignment today. All right, starts out kind of easy, moves into more difficult. It's to see where we're at for sure. Some rules here. Rules so you know once you've simplified or evaluate. Evaluate means get it down to a single number. Find the answer is another way. That's like the slang form of it. Single number usually, or find the answer is another way to think of that. Simplify just means you get it down to simplest form. Okay? Then it says write your answer using only positive exponents. Some notes you may want to just add to yourself here to know once you're done simplifying. 1, no negative exponents. If it's simplified correctly, there are no negative exponents. So like in number 11, is there a negative exponent? Yeah. That means it's not simplified. Okay? That's number 1. Number 2, no zero powers. Why is there no zero power? What is zero power? Yeah. 1. Change it to a 1. Because the zero power is equals 1. Okay? So there's no zero power because that equals 1. Make it a 1. Okay? No first power. Why is there no first power?
It equals number, the base.
Yeah, it equals the base. Okay? Make it the base. Get rid of the first power. All right? And the last thing is, you should not see the same base appear more than once. Okay? Should not see the same base appear more than once. So that would mean like on number 16. Okay? You have the base of -2 appearing twice. This will be simplified when it only appears once. And there's no negative exponents. Can there be a negative number? Yeah, you could have -2, you just can't have a negative exponent. Okay? You don't want to have a 0 or a first power. All right. There you go. You can work together. Do your best on it. I want to know where you're going to struggle, what you're doing well on. Okay, you have about 20 or 15 minutes of class left. You shouldn't have tons of homework tonight if you work hard right now. Okay?